These are the notes for section 9.2, similar polygons. Start with a definition for you. Polygons are similar if they have the same shape and angles. All right, the symbol for similar is that squiggly top part of the congruent symbol. All right, we are going to write that triangle ABC is similar. There's your symbol for similar right there. To triangle DEF. I'm going to go ahead and mark some angles here. These angles are congruent to each other. And then we've got angle C right here and angle F. Those are similar triangle, and it's important to note here that just like when we're writing our congruent statements for triangles, the order matters here for the triangles that are similar too. So just like when we wrote that before, that order is important to that final similarity statement. Again, you can tell which angles are the same by looking at that angle A goes with angle D here. All right, in similar polygons, all similar polygons, your corresponding angles are congruent. Again, those corresponding angles in that example I just gave you, triangle ABC is similar to triangle DEF. Angle A corresponded with angle D, and so on throughout the triangle. And the second part of similar polygons is that corresponding sides are proportional. So we can set up a proportion to show that they're similar. If they're similar, the proportions will be equal to each other. Moving down here to our examples, I'm going to look at these polygons to determine if they're similar and justify our answers if they are. I'm going to start off here with this figure right here. I'm going to highlight some angles for you. Looks like, ooh, that's kind of dark. Let's not do that. Let's highlight our angles here. I got my right angles here. Notice in this triangle my angles are not right angles, so therefore we can say that our polygons are not similar because their angles are not congruent. So in order for those polygons to be similar, just like we saw up here, those angles have to be congruent. Looking at our second example here, first thing I'm going to do is take a look at my angles. I see that I've got my congruent set of angles here. Those are congruent to those over here. And then in my other angles here, I've got these angles are congruent to those angles here. So right away I can start off with saying that my angles are congruent. Now I'm going to look at my sides being proportionate. So my sides, if I set out the proportion, I'm going to move some of these highlights out of here. So now I'm going to look for my corresponding sides. I'm going to look at the 4 corresponds to the 6. So I'm going to set up my proportion of 4 over 6. And I'm going to see if that's congruent or equal to, not congruent, equal to the proportion of the other sides then. My other sides being that 5 and 7. So now I need to look at my cross products to see if those proportions are similar or the same. So for this I've got 4 times 7, fix that. So I've got 4 times 7. The question, this is a question I guess too, is does that equal 5 times 6? 28 does not equal 30. So these polygons are not similar. Okay, and I've proved that by showing that their corresponding angles are, although they were congruent, the sides were not proportional. So in order to be that similar polygon, I'd need to have those congruent angles and corresponding sides that match. All right, moving down here to the next example, I'm going to find the value of x given that got my congruent statement or my similarity statement here. Terrible highlighter color. My similarity statement right here, triangle RST is similar to triangle JKL. So again, just like in congruent triangles, that order matters. So as I'm looking to find my values for x's and y's, I need to set up my proportions because I know that they're similar. I can go with my side ratio. So I'm going to look here. I've got side RS, so I've got 5 in this triangle is similar to JK, which is my x. Now I need to make sure I'm using that 4, so that RT, I'm going to set that equal to my 4. So I use my first triangle RST first. I've got to use that same triangle first in my second proportion. And I'm going to look at my sides JL here. So JL over here is equal to 7. Now I'm going to solve for x using my cross products. So we're going to go ahead and cross multiply. So I know that 4x is equal to 35. Divide both sides by 4. I've got x is equal to 8.75. So that's my first value. I'll go ahead and write that in here. Alright, then the solving for y, I'm going to go ahead and use this same proportion that we knew worked for the first setup that we did. So 4 over 7, again it goes from RT corresponds with JL. I'm going to set that equal to, the side that we haven't used here is that TS and LK. So again, since I used 4 first in the first proportion, I need to use that 6 first in that second proportion over y plus 2. Alright, now using my cross products here to solve, I'm going to say 4 times y plus 2. I set that equal to 7 times 6. Let me erase some of this so I have some more room. I'll move up here. Alright, so then I'm going to go ahead and distribute my 4 here. So this becomes 4y plus 8 is equal to 7 times 6, which is 42. Alright, solving for y. Subtract 8 from both sides, so I've got 4y is equal to 34. Divide both sides by 4, and I've got y is equal to, let's see here, 8.5. So this side here is 8.5, actually is for my y. So that's what we were asked to do, find the values for x and y. Alright, let's go to the next page here. We're going to find the values of x and y given that the two triangles are similar. So I'm told that those two triangles are similar. That's very important to note. Now I'm going to set up my proportions to solve for x and y. Alright, so my first proportion is going to be 3 right here over 2. Those two sides correspond to each other. Setting that equal to, I'll solve for my x's first. 4 over x. Go ahead and set up your cross products. 2 times 4 is 8. 3 times x is 3x. Divide both sides by 3. You've got 2.6 is equal to x. Actually, that's 2.6 repeating here. All right, go ahead and solving for y now. I'm going to use that same first proportion here, that 3 over 2, since that works for that one. Let me get a different color. So now I'm going to use that 3 over 2 again and set that equal to that 5 over y minus 1. Setting up your cross products here, so 3 times the quantity y minus 1, setting that equal to that 5 times 2, which is 10. Go ahead and distributing here, so 3y minus 3 equals 10. Add 3, so I've got 3y is equal to 13. Last step, dividing both sides by 3, so y is equal to 4.3, repeating. And that's all it's asked us for. It didn't ask for the lengths of the sides, so we're going to go ahead and move on then to this last example here. We've got this living room blueprint. I'm going to go ahead and read this. In the blueprint, 1 inch on the blueprint represents an actual length of 16 feet. And we're looking to find the dimensions of the living room. All right, so we're looking at my living room space right here. We're going to find those dimensions. So what is the length and the width? Some other important information on the blueprint down here. The living room is 1.5 inches long by 1.25 inches wide. We're going to use those proportions to solve. All right. So looking at my first proportion that I'm going to set up, I'm going to use that information that was given to us in this first paragraph. I know that 1 inch on the blueprint is actually equal to 16 feet of real space here. So that's going to be my standard proportion that I'm going to use. Now I'm going to use, we're going to do the, let's call our length x here and our width maybe, calling that y. So let's solve for x first. So now this is 1 inch on the top here, and we got feet on the bottom. So when we're working to solve for our unknown width in real life, we're going to use our dimensions that were given. So that's 1.5 inches. And we're looking to solve for that number of feet here. I'll go ahead and set up those proportions here. So 1 inch, so 1x, so 1x is going to be equal to 16 times 1.5. So x is equal to 24 feet here. All right. Now that's one of our that's our width then of our living room. Now we're going to work to find the length of the living room. So we're going to go ahead and use that 1 over 16 again. So again, that's 1 inch over 16 feet. And we're going to set that equal to, now this time we're going to use that 1.25, which is our 1/4 inch, to some number of feet. Looking to solve that, I've got 1x is equal to 16 times 1.25. 16 times 1.25 is equal to 20. And I'm going to label that with feet since that's what we're looking for here. That's what our x is. So then I also have my width right here. So then in my last part of this, it's going to give the dimensions of the living room. So the living room is going to be 20 feet by 24 feet. And again, that's using this diagram that we were given here for our living room, that blueprint. Alright, your first assignment for this section is going to be assignment right here, assignment number 2. It is the next page. Make sure you're doing all the problems you need to do.